Hi, this is Phil from Simply Rhino, and in this video I'm going to take a look at some of the new features in KeyShot 8. This isn't by any means a complete list of new features, but they are, perhaps from the perspective of a Rhino user, some of the highlights. Let's first of all start with what hasn't changed, and that's the interface, and this has been consistent now for the last few versions of KeyShot. Generally on our videos you'll see that we use the light interface. Here we're using the dark interface, and if you're unsure how to change these, simply you go into Edit and Preferences, and in the interface section you choose either the dark or the light theme. The features I'm going to highlight today are as follows: improvements to how liquids are handled, bubbles and displacement, and these two features are in the Pro version only, the new spotlight, scattering media including fog, and finally the new cutaway feature. Now, in addition to these features that we're going to highlight, there's also been changes to how IES lighting is handled. There's a new material called multi-layer optics that can be used to simulate multicolored lenses, image styles that allow you to not only add photographic controls like tone mapping and layers, but also to save these as preset styles. So here, for example, we have the default style, and I've got another image style here where we've reduced the saturation and reduced the mid-tone, so a bit like an ectochrome look. There's also some additional improvements to the Pro version, and this includes new scripting functions, improvements to the studio, and finally improvements to the configurator, including a new feature called Material Ways. This saves possible variations of colors and textures, etc. And this is great for apparel designers, for example. Okay, so now let's get into it and look at some of the new features in detail. KeyShot 8 introduces a new material definition that makes the creation of liquids much easier. In simple terms, liquids can now be created as solids, much in the same way as we do this in V-Ray, Maxwell, Flamingo, and even the new ray trace renderer in Rhino 6. So to explain how the geometry should be created now, it's perhaps easiest to switch to Rhino. So here is the scene in Rhino, and both the glass and the liquid are created as solid volumes. And the important thing is that the solid liquid volume needs to clearly intersect with the volume of the glass. By intersect, I mean that it needs to clearly overlap. So what we don't want is to have a gap between the liquid and the glass, or we don't want the outer surface of the liquid to be coincident with the inside surface of the glass. So as long as the liquid clearly overlaps the inside volume of the glass, then we're going to achieve the proper refractions in our render. And you can see this in this area here and also in this area here. There's another new feature in KeyShot 8 that allows us to create more convincing liquids, and that's bubbles. Here I have the standard liquid beer material, and I've just increased the transparency distance to make the liquid more transparent and lighter. If I go into the material graph and just move this window to enlarge this a little, I can right click onto the canvas here and create some new geometry, and I'll choose bubbles. Plug this bubble texture into my liquid beer, and if I double click here, I'll see the variable parameters that allow me to change the appearance of the bubbles. So I'll just move this window over here a little so we can see the effects as I change this. So the variables that we have are size, that's the size of the bubbles, the variation, that's the way that we can make some of the bubbles look larger than others, and the density of the bubbles, and also the flake limit. So let's execute the geometry at the default settings, and you'll see the bubbles start to appear. Once we execute this geometry, we basically create the mesh that's being rendered, and this is, in Rhino terms, baked off into the render. So let's just increase the size variation here and reduce the size of the bubble slightly, and just increase the density slightly, and take a look at the result that we have here. Okay, so now you can see much smaller bubbles, and let's just populate more of these, and you can see more of the bubbles coming into play now. So this is quite a nice fun feature, but it's also a means to an end to create something that otherwise is very difficult to achieve in a render. This is displacement in KeyShot 8. Displacement has been a much requested feature over the years for KeyShot, and essentially lets you create real three-dimensional geometry from 2D artwork. On this example, these cast iron plates consist only of a single Rhino planar surface, with the three-dimensional relief being created with a black and white image map, much in the same way we would create a bump map. Unlike bump mapping, however, displacement creates real three-dimensional geometry rather than a faked effect. So let's have a quick look at how we set up displacement in KeyShot 8. The starting point would be in Rhino, where I created some line work to describe the strengthening ribs and bolt heads in the cast iron plate. These are created as closed curves. I then took this geometry into Adobe Illustrator and created the fills and arrayed the geometry about. Finally, in Photoshop, I created a PNG file in RGB color space and saved this at the appropriate resolution. The only geometry that needs to go into KeyShot from Rhino is a single planar surface. I've now opened this file in KeyShot 8 and applied a textured iron material, which is one of the library metal materials inside KeyShot 8. I'll then go to the material graph, and I'm going to right click on the canvas, go to geometry and displace, and I'll plug in the displacement to my textured iron material. Then double click on the little texture map here for displacement, and I can first of all apply the texture. So this is the PNG file that I created from Photoshop, and then we can go back to the properties of the displacement. So we have here the height that we can set the displacement to. So the idea of the black and white image is that black will be at 0 and the white points on the image will be of the value that you set in here. I can change the offset and also the resolution, and I can choose the maximum number of triangles that I'm going to allow for my displacement. So more triangles and higher resolution will create a better displacement, but of course this is more computationally intensive. So I'm going to increase these values, and I'm going to set my displacement to start off with to 10 millimeters. Nothing will happen as yet on my material until I press execute geometry nodes. This will generate the mesh and then the displacement, and now my geometry will be created. So just to be clear, unlike a bump map, this creates real depth to the geometry. So what's happening here is that the mesh that we are rendering, the polygon mesh that we are rendering, is being changed by this displacement map. And you'll see this if I exaggerate the displacement height here. You'll see how we can grow this geometry very simply by changing this displacement height. So you can see that the result of this is now much more exaggerated, and although in general displacement, as with bump mapping, is best used with discretion, you can see that it does open up the possibility of creating challenging geometry by simply using an image map. Spotlights are a new feature in KeyShot 8. The metaphor for using spotlights is very similar to that of the existing IES and point lights, in that we simply use a geometry object and apply a light material to it. So in this case I have a sphere that I'm going to use for the spotlight, and then I'm going to take one of the new library materials for the spotlights and drag and drop that onto the sphere, and we'll now see the effect of that light. Now, if I go into the materials themselves and the spotlight material, you'll see I have controls to adjust this. Now, before I do this, I should just say that if you are more used to Rhino than KeyShot, then it may be worthwhile inside of Rhino to save some views. In this case, I've saved render right, render front, render top, and of course the perspective view that I'm going to use here, which is render 001, and then these views will be present in KeyShot when you open KeyShot, and this sometimes gets over the difficulty in understanding where the views are in relation to your Rhino views, and in particularly when you need to do something like move the beam of the spotlight, this can ease that confusion. So you'll see here that my render front view and my render right view are similar to that of my Rhino views. So it's easier now to get those views so I can move the spotlight beam where I want it. When I want to move the beam of the spotlight, all I need to do is to basically select that object and use the move tool on the light, and then I can adjust the position of the light by using the translation tool here. So going back to the controls of the spotlight, first of all we've got the power of the light, the brightness of the light. We can choose lumens or watts for this. We can input a value into the text box here, and then we can use the slider to modify that value. So let's turn this up so it's quite bright so we can see the effect of this. We have then got control over the beam angle. So this is just the width, if you like, of the angle of the beam. Control over the fall off. The fall off is the brightness of the light in the center compared to the brightness of the light at the edges. So if I set this to 0, that light doesn't fall off at all, and if I move the slider to the right, we get more fall off on the light. Another control that we can use here is radius, and this effectively softens the edge of that spotlight and also softens the shadows as well. So far we've just been looking at these basic spotlights, but we also have a set of textured spotlights. Now these add a color or a black and white mask in front of the spotlight to give a textured or a colored effect. So if we look at this colored spotlight here, for example, drop this in again, I'm just going to increase the brightness of this just so we can get an exaggerated effect that you can see on screen quite easily here. So this effectively puts a mask in front of the spotlight to add this color. Now this can be either a color ramp in this case, or of course it could be an image based gradient that you might create yourself. You can see some of the features of this probably better with these mesh masks that I'm going to put in the front here. Again, I'm going to just increase the brightness of this to exaggerate the effect on the screen. One of the key controls here now is the color stencil diameter. This just controls how that stencil works in relation to the light, so moving effectively the size of the grid pattern here. And again, of course, we can still use all the other tools in here. We might want to be more careful, of course, with the radius tool, because we can soften that effect quite noticeably very quickly here. So all in all, these new tools give us a very simple and effective way of creating spotlights inside of KeyShot. Now I'm just going to move back to one of the basic lights that we had in before, and again I'm just going to increase the brightness of this so that we can take a look at another new feature that's in KeyShot 8. KeyShot 8 introduces scattering materials. These can be used on a small scale material basis for objects such as foam, or on a larger scale to add thickness or volume to the atmosphere for effects like fog. These effects can be computationally intensive, but certainly in the case of fog they're showing a lot of promise. Because these are material effects, we need to add geometry to apply them to. So in the case of this scene, we'd need to add a volume to apply the fog to. If I go back to Rhino and turn on the volume here and just pull out of the scene, you'll see that what we have here is a large box that encompasses the scene, and we're going to use this inside of KeyShot for the material onto which we're going to apply the fog. Back in KeyShot, I'll go to the scene and I'll make my box visible. Now at the moment this box just has a matte black material applied to it, and it's not obscuring the view because our camera is inside that box. If I now add one of the standard fog materials, we'll start to see the effect. And at first the fog is so dense that we can't really see any of the scene. So I'll go to the material tab and I'll edit the fog material, and the first thing I'm going to do here is to increase the transparency distance. This will now allow me to start to see the scene. Now you can see that the scene is taking quite a long time to regenerate here. So fog basically is putting particles inside of this volume, and of course all of these have to be rendered. So this, as I've said before, is a computationally intensive effect. The textured spotlights also work really nicely with fog, and these can be great if you're looking to create stage or theatre lighting effects, for example. So let's take a look at one of these. I'll choose the color gradient light and I'm going to increase the power, soften this off a little bit with the radius, and wait for the real-time preview to regenerate. Now you can see that the real-time render has generated a reasonably good quality image. Now we can see some of the particles in the fog, and we can see the effect that the colored ramp on the light is making as it progresses through the fog onto the ground plane. Let's now take a look at scattering materials on a smaller scale. The most common uses for these in, for example, product design would be to create foam and sponge materials, and there's a number of these materials included in the library. I'm going to apply a medium open cell foam onto my geometry here, and this geometry is just a solid box. Now, as with the fog material that we just looked at, these are computationally intensive, and this image will take a while to regenerate. But you can see now that this uses a combination of a texture and also the scattering material to create the foam effect. And if I go into the material, you can see that we have a density texture that's applied here. And in the properties, I can increase the transparency distance, and I can increase or decrease the density. Another thing that I can do is go into the textures, and I can change the scale of the pores in the foam, and I can also change the shape of those. So I can change these, to example, to a square shape, and I can increase the size of those. So you can see there's a lot of scope for customization of these type of materials. Let's just look at the sponge material, and this probably shows better the scattering effect of the light coming through the material. I'll just let this regenerate. The sponge material is particularly computationally intensive, and this is taking quite a long time to regenerate, but you can see now that along the edges of this how the light is coming through this on the thinner where we're seeing a thinner part of the material. And if I increase that transparency distance, we'll see that effect increase. So now the real-time preview has regenerated a little further. We can now see that we're getting much more detail into this material. We can see that having increased the transparency distance and reduced the density slightly, we can see now where we can see through the thinner parts of the material how the light is coming through this, and we have a really very realistic spongy looking material now. So as I said previously, these take a little bit of time in order to resolve, but they are well worth the effort in terms of the fact that we get really realistic materials. Cutaways are a completely new feature in KeyShot 8 and something that has been much requested. Cutaways are very easy to achieve in Rhino, but third-party renderers don't tend to support the Rhino clipping plane, and therefore they need their own workflow. In KeyShot 8, the cutaway is created with a special material type, and we therefore need some geometry onto which to apply the cutaway material. Here's the model of the basin in Rhino, and all we need to do is to create a solid volume that is big enough to clip our geometry with. So in this case, I've just added a large rectangular solid volume, and we're going to use this inside of KeyShot to clip with. Once inside KeyShot, if we show the cutaway material, we can then apply some pre-built cutaway materials to this volume, and this will then cut through the geometry. There are a few limitations with the cutaway material as it stands at the moment, and the first one is that the cutaway material will interfere with the shadows on the ground plane. There is of course a workaround for this, and all we need to do is to go to our edit menu, add a ground plane geometry, and then from our cutaway material we add an excluded node, and we choose that we want to remove the ground plane from the cutaway material, and now our ground plane will render correctly. The idea of excluding geometry from the cutaway is also important for visual clarity. For example, in this case we might want to create a cutaway through the center of the basin, but not cut through the spar jet motor or the waste components. This may be because the section wouldn't read correctly or because the components are not modelled in sufficient detail. So in this case, I've added some extra components to the excluded nodes, and now let's have a look at moving the section to the center of the basin. So I'll change my camera view to the top view. I'll go to my scene and select the cutaway part. Choose the move tool, zoom in a little bit and move the cutaway to roughly the center of the basin. I'll then reset the camera view, and when the real-time view settles down, we'll see now that we've cut through the basin but not through the motor or the waste components. If we subsequently want to include one of the pieces of this geometry into the cutaway, such as the pipe here, we can simply pick this from the excluded node and remove it, and we'll now see a section through that pipe. In order for the geometry to be sectioned correctly with the cutaway and for it to create the proper fills or caps on the section, the geometry needs to be a solid volume. Not all materials will work correctly in all situations with cutaway. For example, liquids and glass type materials, and there can also be issues with coplanar surfaces on geometry and also single surfaces. There's some starting materials that we can use, and once we get into the material itself, we can change things like whether there are caps or not on the material, and also we can change the color of those caps should we choose to have them. So that's all for this video. Thanks very much for watching. If you've any comments or questions, please leave them in the box below. If you found this video useful, please hit the like button, and remember to keep up to date with the latest developments in KeyShot and of course Rhino. For both PC and Mac, you can subscribe to this channel. Thanks again for watching, and I hope to catch up with you again soon in the next video.